Bob, thank you very much for coming in to
You're very welcome.
And talk about a whole wealth of things to do with astronomy and the great beyond. So just a short introduction for yourself. You're a graduate in modern languages, but you're much better known as an astronomer. Having taught French for 26 years at Poole Grammar School, where you met your wife Pam, you embarked on a daring career change in 1996.
Indeed.
Responding to a lifelong love of astronomy, you are now a planetarium operator, taking a mobile dome into schools, youth groups and societies all over southern England. And over 150,000 people have experienced a tour of the universe with you at the controls.
Yeah, they seem to like it.
You're best known in the scientific and environmental community as the coordinator of the British Astronomical Association's Commission for Dark Skies, which aims to turn back the tide of light pollution that has seriously affected our view of the stars over the last 50 years. Glare, light intrusion and sky glow have become the norm nowadays, a situation hardly compatible with a society which is supposed to be saving energy and protecting the environment.
Absolutely.
You were elected a Fellow of the Royal Astronomical Society in 1985 and have been associated with the Wessex Astronomical Society in various offices for many years. In 2010, you were awarded the MBE for your work in astronomy and environmental education.
Yep. And
you are a STEM ambassador, which stands for Science, Technology, Engineering and Maths, seeking opportunities to bring both astronomy to both adults and young people in the South. You've also written a number of books and things that we have with us today. So thanks a lot for coming along. Is there anything in that introduction that we've missed, really?
Well, I do belong to other astronomical societies as well, but there's no point listing them all. I do a lot of work for the area of outstanding natural beauty, Cranbourne Chase area of outstanding natural beauty near Wimborne, where I live.
Yeah.
I've been measuring the dark skies for them because they intend to become one of these protected dark sky areas. There's quite a lot of them in the UK.
Yeah.
And they need lots of measurements of the night sky to show the organisers of this scheme how dark it is there.
How do you go about measuring that?
There's a little thing called a sky quality meter. Here it is. Yeah. And quite simply, you point it at the sky and press a button.
Simple as that.
And it gives you a reading. 10.4. That's a really bad night sky, that is. If we were outside in the darkness, it might read, say, 21 or 22.
Yeah. Is that a good score?
And that's a very good dark sky.
Yeah.
So you can sort of look at your own sky, wherever you live, in the middle of a city or in the countryside, and say, how good is my dark sky? Click. And that's the value you get,
There's also a tool online, I've forgotten the website, but I think it's something about dark skies where it's essentially got a map and you can sort of check the light pollution in your areas. Are they relatively accurate?
Yes, there's an interactive dark skies map. There's a website called Needless with a hyphen in the middle, Needless, I think it's UK or org, and you can adjust the lighting on this map to show what its effect would be on the night sky. And on the website of the Commission for Dark Skies, which I'm a member of, there's also a UK dark skies map where you can check how dark it is where you live.
I see. So getting started then, very I guess this will have to be quite condensed down because the universe is infinitely large, but a tour through the universe, really. Just a couple of general starting out, fascinating things about our universe and what we know about it or what we don't know about it.
I think if you start from home in the solar system, there's still an awful lot, of course, we don't know, but the amazing thing I think about the solar system and recent discoveries of it is the images we've had from spacecraft at Saturn and Jupiter. The Cassini mission, which lasted more than 12 years. Do you remember they crashed it into the atmosphere of Saturn not long ago?
Yeah.
And just look at that website, to the Cassini Gallery. It's named after the French-Italian astronomer Cassini, who was working in the Paris Observatory, and he discovered quite a lot of things about Saturn, so they named it after him. And the photos show the incredible structure of those rings. When I was a little boy, all we knew was that Saturn had a ring around it. And now we know that it's billions and billions of tons of ice chunks, and it's got little ripples and waves in it, and it's sculpted by the various moons that go around it. It's that kind of thing. And the Pioneer probes, way back in the 1970s, 1980s, before they got to Jupiter, it was just a little yellow blob in the sky with 4 little moons. And now, of course, we know tremendous amounts. Just look at the Juno. That's another spacecraft that's been looking at Jupiter. Look at the Juno images of Jupiter. They are absolutely stunning. All these storms and tornadoes and things moving around its surface. The whole thing is just stunning, really. A bit further out, if you're talking about the whole universe, pictures we're getting now of distant galaxies, the interactions between them, the kind of thing that, when I was a kid, was simply impossible to know. And now, of course, we found out all this stuff. It's wonderful.
Yeah, is it Jupiter that's got the red, the sort of the red eye on it?
Jupiter has an enormous storm. It's about 3 or 4 times wider than planet Earth. Imagine a hurricane 4 times wider than the Earth. So don't go to Jupiter.
It's been raging for so many.
It's been raging for
years.
ever since anyone had a telescope big enough to see it. I mean, it's one of the big mysteries of the solar system. There are several explanations as to why this thing just doesn't stop.
Yeah.
But a tornado on the Earth or a hurricane, it wrecks Florida or something and then stops. But on Jupiter, this thing's been rolling for hundreds of years, and it's a mystery as to why it keeps going.
Yeah. In our sort of within our solar system, what kind of developments have we been seeing recently, and what have we kind of got to look forward to at the moment?
Well, Cassini has plunged into Saturn, but there is the New Horizons spacecraft, which revealed Pluto to us not long ago, and that is carrying on into the Kuiper belt, the huge mass of sort of bits and pieces that surround the solar system, towards its outer edge. And it's going to investigate other bodies out there, look at huge asteroidal bodies. There's even a competition to name the next object that it encounters and sort of shows us. And I think a lot of people will sort of have input into this naming thing. I hope they don't name it Rocky McRockface or anything like that, because I'd like it to be called Edgeworth, because there's an Irish astronomer called Edgeworth, and a long time ago he did a lot of work on the outer solar system, and it's called the Kuiper belt because of a guy called Kuiper who also described. But Edgeworth doesn't really get a mention, so I think they should call the new object Edgeworth to honour this guy who did all this work in Ireland. Yeah,
didn't there used to be a planet that was referred to as George?
Oh, George, yes, that was Uranus, or Uranus, as some people rather embarrassingly pronounce it.
Because it was funded by King George or something?
Oh, that's right. It was discovered by William Herschel. I mean, we're sitting here in Dorset, and just an hour's drive up the road is the garden where a man discovered a new planet. William Herschel discovered the planet Uranus from his back garden with his sister Caroline, probably. She was also a very famous astronomer.
Yeah.
And together they worked in that garden in Bath. 19 New King Street, Bath, the William Herschel Museum, worth a trip. And they discovered a new planet, and they called it George because, well, they thought it might be called George because the king at the time, King George, was a patron. Herschel was a sort of astronomer royal, in inverted commas, really. And in the end, I think reason prevailed, and they said, well, look, all the other planets are called after gods and goddesses. So it was Uranus, which is the Greek god of the sky.
Oh, I see.
Yeah.
I see. Obviously there's private companies now like SpaceX and things that seem to be doing a lot to colonize Mars, really, if that's still their sort of primary objective.
They're aiming to sort of take people into space, even tourists, to go to the moon, to Mars, mining asteroids and things like this. There's all sorts of projects. I mean, these projects have been in people's minds for years and years, but now we've got the technology to actually make them a reality.
Yeah. And I don't know whether this is something. I know they do a lot of they like to talk about, the distant future as well as the near future, but they've talked about terraforming Mars. Yeah. Which is, correct me if I'm wrong.
Yeah, it's not a new idea.
Is it not?
No. Arthur C. Clarke and others were talking about terraforming Mars sort of decades ago,
really?
But it was just a dream then. But nowadays, of course, with modern technology and the way it advances, you never know what's going to happen.
So it's a way that you can essentially purposefully pollute the planet, or use some kind of equipment to help melt the icy caps of Mars.
Yeah.
Which will...
They're not huge, so you wouldn't get a vast ocean out of it or anything like this, but certainly it would, I suppose, with future technology, be possible to create some kind of breathable atmosphere on Mars, and you'd have to contend with the fact it's got lower gravity than the Earth. You're not going to change that.
Yeah, a lot more gravity.
No, lower, because Mars is a smaller planet. It's about half the diameter of the Earth.
Yeah.
So if you stood on Mars, you'd weigh a lot less.
Yeah.
If you want to lose weight, just go to Mars.
SpaceX are obviously doing their part, but I guess one question some people have is that some people are still skeptical of the moon landing and things like that. But also, we seem to just kind of be bypassing it now. Before we touch on the moon landing, is the moon still kind of relevant in our sort of search in our sort of space exploration?
Well, if you want to save a lot of fuel, energy and money, just launch rockets from the moon, because it's got 1/6 of the Earth's gravity, and therefore you don't need as much fuel to lift your payload off the surface.
Yeah.
So launching rockets from the moon is a very sort of viable proposition.
Is that something that anyone's...
I don't know if it'll happen. I mean, not in my lifetime, certainly, but I wouldn't mind betting in the future that launches are made from smaller bodies than the Earth, because it's easier.
I see. I'm guessing you've seen the SpaceX, the two rockets kind of coming down.
Yes, I still, I cannot understand, because I'm only a modern linguist, I cannot understand how you can land a rocket vertically. I mean, it's just a question of the right engineering, of course, but it still looks like magic to me.
Yeah, exactly. I'm mega impressed when our drone goes out of signal and comes back and lands exactly where we took it off.
Yeah.
But to that kind of scale, landing two rockets, and I've seen the onboard camera footage looking down the rocket as it comes into land. It's,
well, I forget who it was who said it, but somebody said, 1950s or something, all future technology will seem like magic. And I mean, you look at a USB, and you've got all that information in that tiny piece of plastic.
Yeah,
it's witchcraft.
Exactly.
And so we cannot predict what will happen in the future, because it's always much more incredible than we think it will be, I think.
Yeah, and especially with people like Elon Musk who's sending his Tesla up there.
Yeah,
he's seems to be generating a lot of interest.
Yeah, I mean, national space agencies like NASA and whatever are being now sort of not necessarily overtaken by, but they're being seriously sort of competed with by these sort of very rich people who can afford to afford the engineering.
Yeah, it seems like the SpaceX and NASA have, from the little I know about it, like a reasonly good partnership.
Oh yeah,
I think NASA were pretty instrumental in helping.
It's not a vicious competition. Everybody's working together to get it done.
Yeah. Okay, so. Let's hit the moon landing quickly.
I saw it on my little black and white television. Now, you didn't, I did.
I certainly didn't know. I guess why might people think there's a bit of a conspiracy going on here? It's something to do with the was it during the Cold War?
Well, the Russians and the Americans, of course, were at each other's throats throughout the 50s and 60s, and mostly as a result of World War II. And the Russians consistently got firsts, the first thing to orbit the Earth, Sputnik 1, I remember that, 1957, I think. First man to orbit the Earth, Yuri Gagarin, that was an amazing thing. He came to London, in fact. Yeah. And I was a little lad at the time, a teenager or something, but I remember that. And I think the Americans really needed to score one over the Russians, and Kennedy, rather dangerously at that time for the US economy, he said, this is what we're going to do by the end of the decade, and they actually did it. They spent vast amounts of money on sending people to the moon.
Yeah, it's quite it's almost quite an inspirational speech. I know the one
it is.
You're talking about.
And I think one of the most inspirational things Kennedy ever said about the space mission in general is that, we do these things not because they're easy, but because they're hard.
Yeah, exactly. And so what do you think are a couple of the main reasons why this is definitely sort of not a kind of a hoax, or you filmed in a studio?
May I first of all recommend a website to you, which is badastronomy.com. And this is run by a very educated American called Phil Platt, and he lists a lot of the different things that people believe about space, the universe, space flight, etc., which are simply rubbish. You can see the Great Wall of China from the moon, can't you? Of course you can't, it's rubbish. But people just recycle these myths because they can, and with the information boom that there's been in the last, say, 20, 30 years, such things get passed around much more frequently, much more readily, and they're seen more often. So if you invent a myth, then 1 million people can see it within seconds.
Yeah.
And this is what's happening, I think. Such things are being broadcast. I mean, there are lots of reasons why people think that this moon landing was a hoax, but if you look at it really, I don't think they know a lot about photography and science, and they just get it wrong.
Yeah.
There are no stars in the sky in the moon landing photos. They must be in a studio. No, those photos are taken with a Hasselblad camera at about 1,000th of a second exposure, and you won't get stars. They're not bright enough to show. If you just point a camera at the sky and go clip, you won't get any stars. They're not bright enough. If you do a 10-minute exposure, you get thousands of stars.
Yeah.
And the shadows are so black on the moon, it must be a studio floodlight. No, it's because the moon hasn't got an atmosphere. And in a vacuum, shadows look very black indeed. On Earth, shadows look sort of slightly grey because there's air intervening. And
I see. So on the moon,
there's a lot of science there that people just don't bring in. They don't bring that into the argument.
Yeah.
They don't really know the... another thing too, there were 6 moon missions that successfully landed. One of them, Apollo 13, as we know, didn't and had to come back. And you can fool me once, but you're going to fool me 6 times.
Yeah.
And thousands and thousands and thousands of people worked on the American space effort and on the Apollo moon landing program.
Yeah.
Not one of them has ever been to a tabloid newspaper and said, give me $1 million and I'll tell you all about how they faked it.
Yeah.
I think somebody would have, don't you?
Yeah. I think something I might get onto later when we start talking about extraterrestrial life. I think sometimes people overestimate how difficult it would be for the government to keep such secrets about things and cover-ups not to get out.
That's right. The extraterrestrial debate will rumble on, but as Enrico Fermi once said, the great American-Italian scientist, where are they? If all these creatures exist, why aren't they sitting here with us and contributing to this debate?
So any more fascinating facts about our solar system, things like that?
Where do I start? Just name a planet and we'll find a fascinating fact.
Venus.
Okay, Venus is about the same size as the Earth, And it's known by some astronomers as the Earth's evil twin, because the Earth is, in spite of all the mess we make of it, the Earth is still quite a decent place to live. It's got warmth, water that grows our food for us by falling as rain, etc. Venus is the same size as the Earth. It's a very Earth-like shape, etc. But the temperature on the surface is 500 degrees centigrade. Celsius, and the atmosphere is made of carbon dioxide. Sulfuric acid rains down, and it's hell. So Venus is it's like Dr. Jekyll and Mr. Hyde. It's the nasty twin.
I mean, there's nothing really there for us. I mean, I suppose it's outside that kind of golden.
Well, if you went anywhere near Venus, you'd be dissolved by the acid. I mean, the Russians landed probes on Venus way back in the 70s, I think, but they worked for a very brief time. They took a couple of photos of some rocks, and then they were frazzled, and that was the end of them.
I know we're going to touch on life in the universe, but just in our solar system, whereabouts are we likely to, or not likely, whereabouts are we looking for life? I know one of the planets, is it one of the planets of Jupiter, one of the moons of Jupiter? Europa. They have some gigantic oceans.
Yes, Europa has an icy crust. It's a little bit like looking down at the Arctic ice pack in the winter, all these ice flows that have come together. You get these cracks and shapes, and underneath that ice there is, and I mean I'm no sort of qualified scientist, but we're told that underneath the ice pack of Europa there's probably a tepid ocean, and we're also told that life began on this planet in a warm ocean. So I wonder what's there on Europa. Nobody knows. And in the far, far future there may be a probe that goes there, drills a big hole and finds out.
Moving in. So, if someone's looking to kind of start out in astronomy or astrophotography, where do you recommend, starting?
Well, when I go to schools with the planetarium and show people the stars, that I'm often asked, how do I get started in astronomy? Which telescope do I buy? And the rather surprising answer is, don't buy a telescope, because you won't know how to use it. A 5-year-old can't handle a telescope, really. It's a very difficult thing to understand, especially with a reflecting telescope, where you're looking through the side of the telescope, not sort of straight at the object. And that's a difficult concept too. So start in astronomy with binoculars. And you don't need, if I may, you don't really need that to start in astronomy. I found this in my local market. It cost me £1.99. It's a pair of old Victorian binoculars. They work perfectly well. They magnify 3 times, and with that I can see the craters of the moon. I can see far more stars than you just see with the unaided eye. And that's the way to start. And by using binoculars, preferably if they're big ones, on a good stand, a nice firm stand, because your hands get a bit shaky, you can learn a tremendous amount about the night sky, and you can remember where things are, and then you're ready to get the telescope. It's a bit like being a taxi driver or something. There's no point buying a taxi if you don't know the street map.
That's
and
that makes sense.
When you've been driving around for a long time, forget the sat nav and all that for the moment, then you do. And so get binoculars, learn the night sky a little bit, and then get the telescope.
I see. Yeah, that's something I need to look out for. And in terms of using technology or materials in order to understand what you're looking at, where the planets are and things like that, what do you recommend?
By technology, I mean, if you mean using computer images and maps and charts and things like this, there are tremendous planetarium programs, as they're called. One of them is called Stellarium, for example, and you can navigate around the night sky. You can set the night sky for any date or time that you want, and you can on a cloudy night, you can do a bit of stargazing on a screen.
Oh.
And there are lots of other programs like this. You can get apps for your phone, which, you can point your phone at the sky and it'll tell you what that big bright thing is.
Yeah.
I once remember someone saying to me, sort of waving this app towards the sky and saying, I can't find the moon. And I said, well, it's that big moon-shaped thing up there. So people sometimes rely a bit too much on the technology, I think, rather than using their own eyes. Yeah. But some of this sort of star map technology is really great stuff. It's very useful.
And if you're starting out and you're using binoculars, or even not using any equipment at all,
there's a lot that you can see. Yeah.
What should you be looking out for here? Are you looking out for differentiating planets and stars?
Yeah, I mean, just with the unaided eye, you can see the basic outlines of the constellations, and that's quite fun too, trying to work out if they really do look like the things they're supposed to be. If you look at Leo the lion, you can join up the dots and play dot to dot with that, and it does look a little bit like a lion. And Triangulum, the triangle, is really good because it's 3 stars, and therefore it definitely looks like a triangle. Some constellations look nothing at all like the things they're supposed to be.
Yeah, some of them are.
But there's meteors, of course, shooting stars. That ideal astronomy for the unaided eye, because you can't see meteors with a telescope because it only shows you a tiny area of the sky.
Yeah.
So you've got to look all around. It's useful to have a pair of binoculars handy because some of these meteors, they leave a big train behind them of heated gases.
Yeah.
And you can't see that with the eye, but if you look at a really bright meteor trail with binoculars, you can sometimes see this sort of ghostly trail behind it for some minutes. It's quite a fascinating thing.
Oh, really?
Not a lot of people know that. You don't necessarily just need eyes for meteors. You can use binoculars on them as well.
Yeah, yeah. And when we see a shooting star, then what are we really looking at here? Because they, it's not like they go from one side of the sky to the other.
No, they generally sort of flash across the sky for a short distance, apparently, and then stop. But what's happening here, you've got small pieces of space debris. Some of them might be the size of a grain of sand on the beach. Some of them might be the size of a pea or something like that. And they just burn as they hit the atmosphere. I mean, if you rush through the air that fast, you burst into flames as well. Yeah. It's all, heat destroying bits of space debris, and that's what you're looking at.
Yeah.
Anything very big, for example, this is a chondrite from the Sahara, and that fell about 5,000 years ago in Algeria, and that's too big to get burned up. I mean, it was much bigger when it started its journey, no doubt, but it's survived the fall. Yeah, and it's been found as a meteorite.
So what size could that have potentially been?
Well, some of the meteorites that have hit the Earth in the past, I mean, the one that's supposed to have done for the dinosaurs 65 million years ago, that might have been 5-10 kilometres across. And something that size, if it hits the Earth, is going to sort of be a global sort of change,
Yeah. So when you see a shooting star, you're not seeing something that's a million miles away.
Oh no, it's in the atmosphere, not far above your head.
Yeah,
a few tens of kilometres above your head.
Yeah, that's interesting.
Yeah.
You say that you see the aurora, the northern lights.
I've seen it
from your back garden.
My back garden. Yep.
So you don't need to.
Yeah, people fondly think they have to go to Alaska or Finland or somewhere to see the northern lights. Well, you'll see it far more frequently in places that are quite far north. But in Scotland, for example, if the weather isn't too cloudy, you can see the northern lights quite a few times a year in the south of England. I mean, I've lived in my current house for 35 years now, and I've seen the northern lights, the aurora, from my back garden about 20 times.
Oh, really?
And people can't believe. They say, oh no, how is that possible? They say, well, if you sit indoors watching the television all evening, you're not going to see them. You just got to keep looking.
Yeah.
And just stick your head out the back door or wherever. If you've got street lights right in front of you, obviously it's going to be a bit of a problem. Light pollution has destroyed the view of the northern lights for most people in the UK. But if you've got a reasonably dark sky, have a go, have a look, and you never know what you'll see. You can get aurora alerts by email from various websites.
Yeah, I see. And you're looking out for... you wouldn't necessarily get the green colour, would you?
No. Don't be misled by all the wonderful things you see on screen.
Yeah.
Sometimes aurorae are just little faint glows, little faint red patch in the sky, or a little ray coming up from the horizon.
Yeah.
They're not always the big fireworks that you see on the sort of the cruise line adverts. But sometimes it can get quite spectacular. I saw the enormous auroral display of March the 13th, 1989, and this was from the south coast in my back garden in Wimborne. The whole sky was covered with vivid dancing colours, and it lasted for hours.
Yeah.
And the day after, I was raving about it, showing people my photos, saying, "Oh, I never saw that.
Yeah.
You want to get out more,
Yeah.
It was fabulous. And it knocked out half the power in Canada, apparently, because,
Really?
of course, auroral activity is quite dangerous. If it's really, really strong, it can knock out satellites and, earthbound electrical systems.
Yeah.
It's one of the things that you have to worry about when you launch your, $10 million satellite.
Yeah.
Something like that can simply knock it out.
So, keeping on the topic of sort of starting out in astronomy, you've practiced for a bit with binoculars, you've studied the sky a bit just with the unaided eye. When you look into then moving to the next step, is that a telescope? And if so, what kind of telescope should you be looking for?
Well, I think a refractor, this is sort of what you might call Lord Nelson's telescope. You look through one end and the light comes in through the other. That's quite easy to understand and use, The really important thing is don't buy cheap telescopes. You think you've got a big bargain, but they're usually rather poorly made. The quality of the glass is not good.
Okay.
Spend money on a decent telescope.
So what kind of price range would you consider?
Well, if I was looking for a small refractor telescope, one of these see-right-through telescopes, I wouldn't spend less than about 150 quid on it, or say 200.
Yeah.
Because you want quality. It's so many telescopes get discarded in sort of garages and lofts because they don't work properly. And, you get what you pay for. It's true with any telescope. So that's a good one. Make sure that you've got a firm mount for it.
Okay.
I had a really weird mount on my first telescope many, many years ago. It was a sort of woodworker's G-clamp, and you just screwed the telescope to a gate or a fence with this clamp, and off you go, and that was great.
Yeah.
But some cheap tripods, sort of small photographic tripods and things like that, they can be a bit wobbly if you put a heavy weight on them.
Yeah.
So firm mount is most important, and don't buy toy telescopes. Get something worth having.
Okay, so here's a question for that I'm quite interested in. I've read about that seeing the rings of Saturn through a telescope is apparently one of the most profound kind of accessible experiences.
I'm absolutely sure that's right.
I'm assuming have you seen it yourself?
Yeah, people say, wow. I mean, if Saturn's in the sky and you're having a sort of public star party, the first thing you show them is Saturn, because everybody goes, wow, it's an amazing thing.
Yeah, I mean, I guess it just really brings it to life.
That's right. You see this little thing. I think the wonder of it is you see this little thing hovering in front of you in the telescope field. You can see the little rings. And you're actually looking at the planet. It's not a photo of it or a computer-generated image. It's the real thing. And you're seeing light that's been travelling towards you for hours and hours from Saturn. And it's a telescope is a time machine, isn't it? You look at the Andromeda Galaxy, you're seeing light that's been travelling since before the human species was really what we understand as a human being.
Yeah.
2 million years.
So, what kind of equipment do you need in order to be able to get that kind of
Yeah,
image
to get good detail on planets and things, you obviously need a slightly larger telescope. A good reflecting telescope, this is the kind of telescope where the light comes in through one end and then it hits a mirror inside and gets turned through 90 degrees.
Yeah.
So you look in through the side of the telescope. You're not actually looking at the thing directly. You're looking at it sort of through an angle. And I think a Dobsonian telescope is the best kind. Somebody called Dobson invented it, and so it's called the Dobsonian.
Yeah.
And this is very simple. It's a tube mounted on a rotating platform. And so it points to anywhere in the sky. The tube goes up and down, the platform goes round and round, so it points anywhere you like. And it's very easy to find things through those. And the really big ones, say, 10 inches in diameter, 25 centimeters, whatever, is something that will show you a huge amount of detail of the craters of the moon, moons of Jupiter, all sorts of stuff.
Yeah. I've experienced using one of those, and they just didn't look like the traditional telescopes to me. They didn't have a big pane of glass at the top like you might expect. It's just a gigantic sort of hollow tube.
Well, they do have lenses and mirrors and things, but Dobsonians, as I say, are you just haul them around, and it's not difficult to point them. It's the same sort of thing as pointing a rifle or something at a target. You just look through it, look through the finder, and there it is.
Yeah. And astrophotography.
I'm not a sort of great astrophotographer. I take the odd picture, but again, it's not difficult to take simple pictures of the night sky. I've got an ordinary sort of medium-sized digital camera, firm mounting. Don't have it wobbling about. You must a really good firm mount.
Tripod.
And most digital cameras, of course, can take different lengths of exposures. So you can take a photo of a really bright object like the moon or a Venus or something like this at a fraction of a second exposure. But things like galaxies, the Andromeda Galaxy, you might need, say, half a minute or something. Yeah. And you get a camera that can expose for different times. The great thing about digitals, of course, is that you can see what the photo you've just taken. Yeah. Unlike the old days, of course, when you sent it off to somebody to process, and a week later you got your photo back. Yeah, exactly. And just to clarify, if you've got that, like a 30-second exposure, that means the camera's just taking in light and taking essentially one photo over 30 seconds. So all the light coming in builds up on the sensor and forms an image.
So in sort of travel and holiday videos where you see time lapses of the night sky, and you just with incredible clarity, it's not like that to the human eye. It's
the human eye isn't a camera. The human eye forgets what it's seen, and then it sees it again, and it forgets it, and it sees it again, sending all these messages to the brain. And the camera just stores the information. Your brain doesn't store images, of course. It just sort of sees them momentarily and then goes on to the next object. Yeah,
but with a reasonably priced digital camera, you can get reasonable astronomy.
You can find good digital cameras in charity shops, second-hand shops, photographic dealers. Yeah, you don't have to spend a fortune on a camera. I do know people who've got cameras that they've spent thousands on, and they spend hours and hours processing the images to make them look just right. And that's wonderful. I mean, if that's sort of the sort of thing that you like, but I just haven't got time for that. Yeah, I'm too busy going outside looking at the sky, rather than processing an image for 2 or 3 hours.
Yeah. So if you're into this thing, but you're currently living in, say, London or Birmingham, and you get a lot of light pollution.
Oh, the dreaded light pollution.
Yes. What kind of what can they do? What are some targets for them to look out for?
Well, if you live in a big city, the moon is the great thing, really. It's not there all the time. Some people fondly think the moon's in the sky every night, but obviously we live on a big round Earth, and it's round the other side sometimes. You can't see it all the time. It's next to the sun as well. and in the daytime sky. But when the moon is in the sky, from a city, any small telescope, even a largish pair of binoculars, will show you a lot of detail on the moon. And a lot of urban astronomers are simply moon specialists, because that's about the only thing they can see with any ease. You can study the sun, of course. That's astronomy, the sun. Astronomy doesn't just happen at night. The sun is an ordinary middle-sized star, and the great thing about the sun is it's really close, so you can see tremendous detail. Warning, never look at the sun through a telescope unless you know exactly what you're doing. There are special telescopes designed for looking at the sun. But if you don't know what you're doing, never look at the sun. You'll be blinded for the rest of your life.
Yeah, I've heard that.
But study the sun, by all means. You can project an image of the sun. You don't need to look through a telescope. You can set up a little screen behind the telescope. There's lots of websites and things that tell you how to do this. And you can see an image of the sun with all the sunspots and things, inside a little box screen. That's quite interesting.
Wow. Can you introduce us a bit into exoplanets?
Yes, this is I think one of the most wonderful things that's happened in astronomy over the last sort of 20, 30 years. We used to sort of be completely ignorant about whether other stars had planets. But it does seem ridiculous that the sun would be the only star out of billions and trillions of stars in the universe that has planets. It's probable that stars have planets because the sun's got them. And I think it was a pair of astronomers called Kellos and Mayor, and they discovered a planet going around a star in the constellation of Pegasus about 20, 25 years ago, something like that. And since then, clever telescopes have discovered planets going around thousands of nearby stars. So it's quite probable that our little corner of the universe isn't unique. It must be pretty much like other corners of the universe, so perhaps they've all got planets.
Yeah. And the way you measure this, because obviously if you just point one of these larger telescopes at stars, the glare from the stars,
you won't see a planet through any normal telescope.
So the way that they measure it, if I'm correct, is say you've got the sun, even if you're looking at a star, even if the tiniest object or planet
goes across the front of it,
that light that's coming in from that star dips slightly.
Yeah, this is called the transit method. And you just look at the brightness of the star, you meter it, and the brightness will dip. If Jupiter crossed the face of the sun, you were sort of outside the solar system, and Jupiter crossed the face of the sun, it's a pretty hefty planet. It's a tenth of the diameter of the sun. And so if Jupiter crosses the sun, you'd lose a reasonable amount of the sun's light. And that would tell you that there's a big planet in the way.
Yeah.
And you can time the transit, as it's called, and from that you can work out something about the orbit of the planet and the
and how many
speed of the planet. So all these thousands and thousands of exoplanets that have now been discovered, that's quite exciting, because it throws new light on the question of, is there life in outer space? Well, if there are countless planets out there, then the chances of there being life is obviously greater, because there's more places for things to live.
Why are they called exoplanets?
Well, exo simply means outside, so they're outside the solar system. They're planets that aren't in the solar system.
Great. Okay, so 14 Pioneers of Astronomy, which is something that you cover when you go out
that's one of my talks.
And do talks. If we don't have to go through all 14, but what are some kind of key players here?
Okay, if you tried to list all the pioneers of astronomy, we'd be here all night, but the people I talk about, I think the people I'm most interested in are Galileo, for example, in Italy, and something like 400 years ago. He made a tremendous number of discoveries. Some people think he invented the telescope, but actually he was given one by somebody else. It was invented in Holland, in the Netherlands, by a guy called Lippershey. And somebody gave Galileo one of these small telescopes. And with it, I mean, it was only a pathetic little telescope. In modern, by modern standards, it would be a pretty poor thing. But he discovered the moons of Jupiter, which gives a great insight into the way things work in space. The Earth, some people in those days, not everybody, thought that the Earth was at the centre of everything. Yeah. And then Galileo said, no, look, there's something else with things going around it too. So, and he looked at Venus and discovered it had phases like the moon, which shows that it's nearer to the sun than we are. He looked at the Milky Way. He was probably the first person to systematically look at the Milky Way through a telescope. And he said, you idiots, he said, it's not milk, it's stars. I've seen it with my telescope. And these people should really be, celebrated as they are in the science community, because it was risky to, suggest at times that... Yes, Galileo, he was tried, I think it was 1633, he was tried for saying various things that went against the tenets of the church, etc. But in fact, his book was on the list of banned books until quite recently. And but I think one of the main reasons that Galileo went to a court to be tried was that he wasn't a very sociable guy. He was a sort of rather grumpy old scientist, and he made a lot of enemies. A bit like Isaac Newton. He was a great man, a great thinker, discovered huge amounts of things which advanced science. But he wasn't a very pleasant person at times. He had his enemies. And it's very interesting to look at the personal lives of all these old scientists as well as what they discovered. Fascinating subject. Newton is a very good case in point as a pioneer of astronomy, because, of course, he invented the Newtonian Telescope, the reflecting telescope. And his first one, a very small thing. I've actually seen it in a glass case in an observatory somewhere, and a new way of looking at the night sky. And there's lots of advantages to a reflecting telescope. They don't have the kind of colour problems that you get with refracting straight through telescopes.
Okay. Going back to outer space, so and things like meteorites, comets, and asteroids. Should we be more worried about these things?
If life on Earth ends, it's a pretty good chance that it'll be because something enormous has hit the Earth from outer space. It's a very, very unlikely event. I mean, your chances of being hit by nobody in the whole of history has ever been killed by a space rock, as far as we know. And your chances of being struck by something falling from the sky, I mean, you'd probably stand more chance of winning the national lottery every day or something. But the possibility is there, and we really must, and a lot of astronomers and even politicians are saying this nowadays, we really must keep an eye on the sky, because now we have the technology to push these things out of the way. They didn't have it 65 million years ago when something hit the Earth near what's now Mexico and destroyed half the species in the world, So keep an eye open. There's a lot of stuff near the Earth, and quite regularly we're bypassed by large objects, say hundreds of meters in diameter, closer than the moon. It's just that the Earth is a pretty small target when you think about it. So, catastrophe from space, highly, highly unlikely, but just keep your eye open. That's the message, really.
Okay. And any, large scale, thing like we saw with the dinosaurs, would we get noticed for that sort of thing? And how often are these likely to come across?
If the object is coming from the direction of the sun, it's not easy to see, is it? Because it's daytime sky, etc. the likelihood is that the thing would be coming at you from another direction, and therefore you'd be able to see it in a dark sky a long time. If it's a really big object, you'd be able to see it, millions of kilometers away. But look at the Chelyabinsk meteorite of 2013. You might remember that. It smashed all the windows in a Russian city. Shockwave from the thing as it disintegrated. It weighed possibly thousands of tons, that thing, and it came from the direction of the sun, so nobody knew it was coming. And on the internet you can find hundreds of videos from dash cameras and bus cameras and things of this thing crossing the sky. So that's a warning to the human race. Don't get too complacent. Use as much technology as you can to keep looking at the sky, just in case. And I emphasize it's highly unlikely that this will happen. But it's happened before.
What was it was 250 million years ago that the one wiped out the dinosaurs?
No, it's 65 million years ago. The end of the great dinosaurs. I mean, they're still around chirping in our gardens as birds, but that's another story. But the big dinosaurs passed away at the end of the Cretaceous period, and that coincides with the fall of this massive object near, the Yucatan Peninsula, as it's now called.
Wasn't there another event like that on a similar, or if not bigger scale, millions of years before?
Several catastrophic. One of the great driving forces of evolution is catastrophic events, partly from outer space. And I've got a piece here of the meteorite that fell. This is a mixture of Earth rocks and space rocks. It's a breccia, which is sort of a pudding, if you like, of different kinds of rock. And this one comes from a crater near Rochechouart in France. And that fell 205 approximately million years ago, and it completely changed the species pattern on planet Earth. Because there were. I was reading that there was a whole plethora of different dinosaurs before the ones we know nowadays from things like Jurassic Park. That millions and millions of years before them, there was a whole other range of species walking the planet that all got wiped out by another meteorite before and dinosaurs came through. And some people think that this is because the meteorite hit the dinosaurs on the head, but of course if something that big, we're talking say 10 kilometers across or something, if something that big hit the Earth, it would send up an enormous cloud of red hot debris. They would rain down all over the world, set fire to all the forests and things like this. And so you'd have the sky full of dust and ash and all sorts of rubbish for possibly years. And if the sun don't shine, the plants don't grow. And if you're a brachiosaurus that eats a ton of leaves every day, you're in trouble.
So, is it naive to think that there is no other life out there?
Yes, I mean, given the fact that we now know that there are planets orbiting nearby stars, quite a lot of, thousands of nearby stars are known to have planetary systems. Some of them have quite a few planets, just as the Sun has a good number. And given that the number of stars in the observable universe is just unimaginable, somebody once theorized that if you went to every sandy beach in the whole world and counted the particles of sand and multiplied by about 10, that's around the number of stars we can sort of detect in the observable universe. In all those galaxies, billions of galaxies that are known, there are huge numbers. If they've all got planets, how many planets must there be? I mean, there's no such number. It's completely beyond our comprehension. And you're telling me that this is the only one where the miracle of life began.
Also this is the only kind of the only solar system we know, and it's got life. So there's no reason to believe that.
I mean, that the whole history of astronomy shows us that we're nothing special. I mean, people used to think that the Earth was in the middle of everything. The Egyptians saw the stars crossing the sky and thought, oh, that's nice, the sun god's put us in the middle, And then we thought that we lived in the middle of our own galaxy, and in the 1920s that was disproved. We're just a suburban star, the sun is sort of 2/3 of the way out. And then we thought the Milky Way was a really big galaxy. No, it isn't. It's a sort of average size, etc. And so the whole history of astronomy has been deflating our vanity. We're nothing special. So why should this be the only planet with life on? If you look at it from a purely scientific view, life is a chemical accident billions of years ago and it's proceeded from there, then, there's chemicals elsewhere too. Why can't that happen somewhere else?
Yeah.
And if you look at it from the religious point of view, which many people do, then if God is a creator, what is God doing just putting life here and forgetting the rest of the universe, which he has made, or she has made, or it has made, let's not be gender specific about God. And Bob is a builder, so when he's built a house, he goes and builds another one, doesn't he? Because he's a builder. So God is a creator and puts life on this planet. And does he just stop there? I don't think so. He's a creator. That's his job. I'm not a religious person myself, but that's one way of looking at it. I think I don't see why, if there is a God, that it would she would just concentrate on one tiny speck of the universe.
Well, also, as well as the billions of stars that are in the universe.
More than billions, trillions, quadrillions.
There's there's a paper that Stephen Hawking released a couple of days before his death. That was I reading that it backed up the theory behind the kind of the multiverse. I don't know if you know.
Well, there we are. I mean, that makes the picture even bigger, doesn't it? If we are one universe of many, that there is supposed to be a little bit of evidence that there are other universes. People have seen sort of patterns in the microwave background of the universe, which suggests that there may be other sort of large objects touching our universe. I don't know a lot about it, but it's something that you could investigate.
So, especially with all of these stars about, there's even some planets within the Goldilocks zone that we've discovered, right? Yeah. And so the Goldilocks zone is not too hot and not too cold. Too cold,
yes. There are lots and lots of other factors, like is there water? Because you couldn't imagine life that didn't have some kind of liquid medium, because there's, signals and chemicals have got to be transmitted and exchanged, etc. And you'd have to have I think possibly some scientists think that the moon has been very, very important in the evolution, the life processes, because it's partly the moon, of course, that dragged life out of the sea and allowed it to live on the land. If there wasn't a tidal zone, which is constantly wet and dry, sea creatures might never have been able to adapt to living on the land. So they were amphibians, the word amphibian means double life. And frogs and things in the garden, they need to be in water for some of the time. They lay their eggs in water. We spend the first 9 months of our lives in a bag of water. Why? Well, because that's just evolution, isn't it? And if life had never been able to get out of the water, you would be a huge intelligent fish. It's a thought, isn't it?
Yeah, certainly. So, and staying on the topic of extraterrestrial life, I used to be someone that when I was younger, I used to be kind of fascinated with places like Area 51 in Nevada, and thinking, they got these, secret UFOs locked up in there. What convinced me otherwise was when I started to learn about astronomy, and I never properly studied it, but I was interested in it, and I realised that surely if we had something on our planet, like a UFO or something like that, our whole approach to looking for extraterrestrial life in institutes like the SETI Institute and things like that would have completely changed.
I don't really see scientists concealing the fact that they've made such an incredible, huge discovery.
Yeah.
I mean, would you keep it under wraps if you'd made that discovery?
Well,
scientists are human beings. They like to show what they've done, I'm sure.
Yeah, so the WOW signal,
and
for
so,
example,
well, that's something that's still debated about whether that was just an Earth signal that's been misinterpreted or not. But that was 1977, I believe. And if that particular sort of burst of noise from outer space is some kind of artificial signal, that's fine. I mean, that's a bit of evidence, but I don't think we can rely too much on that one.
No, but I think the interesting thing about the WOW signal is that after it came in, I was reading that apparently 5 minutes later they got a call from the New York Times or something, and so there wasn't. It's not necessarily something that the government are completely all over, and military people and guns walking around these places trying to keep these things secret. I got from that if something
I've never actually heard of that happening, so I don't
Really?
know. Yeah, perhaps you've been looking at different websites.
Yeah, I'm trying to think where I got it because there's a lot of uncredible sources out there. But I guess what I learned is that it would take a lot to keep such a big secret. And so from there I kind of concluded that there's nothing in it really going on in Area 51 to do with those sorts of things.
One thing that often strikes me is that people say that they've seen activity in the sky that can't be explained, and so therefore a UFO is a very useful term. It's an unidentified flying object. I've seen things in the sky because I look at it more than most people, I suppose, and I couldn't explain them. As a really good example here is I was observing the sky from the cliffs at Bournemouth years and years ago, and I saw this inverted orange triangle hanging over the sort of Swanage area.
Yeah.
And I thought, what's that? I've never seen anything like that before. It's just a sort of orange triangle. And for years and years and years, I hadn't a clue what that is. And so I could have naively thought, well, that's probably an alien spacecraft then. I jumped to the wrong conclusion and say, this is something absolutely weird and out of common experience. And of course, science teaches us that you shouldn't think like that. You should immediately go for the simple, obvious explanation. And if that doesn't fit, then okay, you can up the ante a bit, But somebody, I was talking to talking about this to somebody not long ago, and they said, well, don't you realise what that was? It's a hot air balloon. That's what they look like at night from a distance. You turn the burner on, and the bottom of the balloon glows orange, and then they switch the burner off again, and it disappears. And you've got this triangle floating up in the sky in the distance, and it looks like a little UFO. It's actually a hot air balloon.
Wow.
I don't know if they're operated very often at night, but this one was.
No.
And there you go. You see, things can be explained if you know things.
Yeah.
And this is it. You mustn't jump to the conclusion that it's something really weird. It's Occam's razor, as they call it, isn't it? You mustn't assume that something you don't understand is really, really weird and unusual. It could be something quite simple that you just don't have the knowledge to identify.
Yeah.
And another thing is that, people say, I saw this crazy light hanging over the airfield, etc. What was it? Was it an alien looking at the aircraft? Well, actually, if an alien creature came from huge distances away, the journey would take vast amounts of time, the amount of energy expended would be enormous. Would they just float about in the sky looking and then go back home again? I don't think so. They'd probably land on the lawn of the White House and say, look, I've made this massive, great journey. This is really, really important. Talk to me.
Yeah.
I don't think they just flit about in the sky and go home, do you?
Yeah.
If you went to San Francisco or something for a holiday, would you just have a look at it from the plane and then go back to London? I don't think so. You'd want to see it. You'd want to talk to the people. You'd want to experience the nightlife and all this, And so I'm a bit, it's very difficult, I think, to envisage travelling across such distances because you'd say, well, the nearest star to us, which is unlikely to have, on this, in the scheme of things, living creatures on a planet going around it, is 4 light years away.
Yeah.
So to get here at the speed of light would take 4 years. Now, hang on, you can't travel at the speed of light. Just read Einstein. Your mass becomes infinite. Time stops. It's impossible. It's against any law that we know of physics.
Yeah.
So how about travelling at half the speed of light? Well, still a bit difficult to achieve. I mean, look at the amount of energy you'd have to expend to travel that fast. And if you hit anything at that speed, you'd be vaporized. A tiny speck of dust or something might do you irreparable damage.
Yeah.
And so you'd have to travel a bit slower than that, perhaps. And then you're starting to talk about long periods now. You're travelling from, let's say that there is a star with life on one of its planets about 100 light years away.
Yeah.
So you travel from that at, say, 1/10 of the speed of light. It's going to take you 1,000 years to get here. How do you do that? I mean, are you going to live that long? I don't know if any species will live that long. It seems, from looking at our planet, that species are sort of programmed to, have a short lifespan. Otherwise, the planet would get a bit full, wouldn't it? And so, therefore, how are you going to get here without putting yourself in some kind of frozen state? And I don't think it's possible myself. I just don't think that you could travel fast over such huge distances with any meaningful purpose, because let's say that you wanted to go to a nearby star system. It's going to take you 1,000 years to get there, 1,000 years to get back, a few years to have a look at it, etc.
You have to travel as a community, wouldn't you, in order to...
You'd have to have sort of, how many people are going to sacrifice their life, bye-bye, everybody I know, I'm not going to see you ever again, I'm not going to see the planet Earth again. I wouldn't do it.
I'm sure there's
it's still a big question, of course. I would love to know that there are living things in other parts of the universe. It would be a wonderful discovery. Yeah. But I just don't think it's ever going to happen. That's just my opinion.
Okay, so I'm conscious I don't want to make this a debate or seem like there's, like the kind of, I think the media kind of did with climate change, but flat Earth.
Yes, flat Earth
is picking up.
Well, it looks pretty flat, doesn't it, really, when you stand on it? And you can't blame people for assuming that. But, of course, there's so much... can I just go through a few of the reasons we think that the Earth is round? Yeah. It's not me, it's the ancient Greeks, I think it was it Pythagoras or somebody who said that, look, you can see that the shadow of the Earth on the moon is round when there's an eclipse. And the Greeks knew what was happening. They worked out that the sun was in one direction, the moon was in another, the Earth was getting in the way. And so, look, the shadow of the Earth is round. And so, therefore, it must be a round Earth. Yeah. They saw ships. I think one of the Greeks wrote about this too. They saw that ships that left port disappeared below the horizon. Oh, they've sunk. No, they haven't. They'll be back. Don't worry. It's just a phenomenon. It's because the sea does that. You could say, for example, go to Australia and look at the stars. They're all different. You don't see the pole star from Australia because, of course, it's the northern pole star is up here. Yeah. If the Earth were flat, you'd see the same stars around the sky wherever you were. And you don't. You see different stars. Even the Greeks knew that too. Yeah, it's ignorant of physics. But I think the killer fact here, the really telling fact, is that we look up into the universe with our telescopes, and all large bodies in the universe are round. Yeah, the sun, the moon, even sort of largish asteroids like Ceres, which is now an official dwarf planet. It's about sort of 500 miles, 800 kilometers across, and that's round. And so how come then that all these other bodies, planets, asteroids, some of them, stars, they're round? So how come we're different? The whole history of astronomy teaches us that we're nothing special. Yeah. So it's pretty likely the Earth as a planet is the same as them. It's round. To think that you're unique in the universe, I think is very vain.
Yeah.
Isn't it?
exactly.
Yeah. I'm the greatest. I'm the only one of my kind. No, I'm not. There's 7 billion of me.
Yeah, exactly. So the last thing I wanted to talk about was light pollution and the Commission for Dark Skies,
Absolutely.
which you're a big part of. So can you briefly explain the problem with light pollution and what you're trying to do about it, and the Commission?
Yeah, well, as a little boy in the East End of London, just after World War II, all the street lights used to go out. I used to go out there and look at the stars and think, wow, but no child in that area ever sees anything in the night sky now apart from the moon and a few bright planets because of light pollution. I brought along my trusty little LED table lamp here to give a kind of demonstration. It is possible, because light travels in straight lines, as we all know, it's possible to put light exactly where you want it. There you are. The table is lit. The ceiling, isn't lit by this lamp. But of course, lights aren't always pointed where they're needed. And so now that's dazzling me. It's supposed to be lighting the ground, around my house or something. It's supposed to be lighting a street. But why is it causing me an uncomfortable glare? It could be dangerous when I'm driving. So let's put it where it's needed. There you go. That's the solution to light pollution. You don't need to switch them all off. We're not crazy people who want to switch lights off and plunge you into medieval darkness. Lights should be as bright as they're needed. Look, you can actually, make lights dimmer. You can do all sorts of things with them. You can change the, there's a sort of warm white light, an amber LED. Why can't LEDs be amber? They'd give us so much more sort of comfortable view at night. But councils and other organisations seem to be insisting on this harsh white light that we're getting everywhere. And the night sky, which could have been saved by LEDs, the old sodium lights used to glare all over the place, and LEDs were going to be the solution. Really directable lights, really versatile lights, remotely controlled, and it's not happening. Instead, we're getting this kind of thing, if I can point that at the camera.
Yep.
This is a very typical LED exterior light that people put in their houses and factories and warehouses and things, and it's got no light control whatsoever. I've taped some little strips on there. You can see that this light has an upward component. It shines into the sky. It shines into your eyes. It shines all over the place. Why? Isn't it supposed to be lighting the car park underneath it? Of course it is. What the hell's happening here then? The light goes everywhere. There's still no control of lighting. And governments, there's only one country in the world that has a fairly comprehensive light pollution policy, and unfortunately not everybody lives in Slovenia, so well done Slovenia. And why doesn't the government wake up to this and simply save vast amounts of energy and money and make the night a comfortable place to be, rather than glaring this into everybody's eyes? That's light pollution. If it's cured, everybody wins. We save money, we save energy, we have a comfortable environment.
Lovely. So, and these smaller lights they're contributing. They're making their small contribution to the light pollution.
Yeah, well, you have 1 million of those, and then you've lost your stars. And the simple fact is, of course, that light travels through the atmosphere in straight lines, and so even if you have a little bit of light escaping above the horizontal, you'll be able to see the effect of it from miles away. In the middle of the Australian outback, for example, you can see the distant glow from big cities like Sydney from hundreds of kilometres away. Why? Isn't that light supposed to be helping the people of Sydney to see what they're doing at night? Why can you see it from the outback then, where you should see the beautiful night sky that is the heritage of all human beings? Why should we rob our children of the view of the night sky just because they happen to live in a city? If all lighting were controlled, you don't need to switch it off. If all lighting were controlled, then we'd see a lot more of our universe. Because if we think that the Earth is the only thing that exists because we can't see anything else, we get a really sort of skewed, damaging view of what life's all about, I think.
So, is this affecting wildlife?
Absolutely. The number of mammals, reptiles, birds that are severely disabled by lighting. I mean, you can hear songbirds singing in the middle of the night. Well, I mean, that might sound very pleasant, but a bird with insomnia doesn't function very well. If you can't sleep, you don't function very well. And a lot of the new LED lights have got this blue component which mimics daylight. And every species, well, with certain exceptions, every species on this planet has been evolving for millions and millions of years to have a day and a night, the circadian rhythm. And suddenly, we've got a day and a day. We've got daylight lighting at night. And if the American Medical Association, which I think probably knows what it's talking about, says that light pollution is a health hazard, I think I'd agree with them. So we are destroying a lot more than just the visibility of the night sky. This is not just about stars. It's about wildlife. It's about comfortable living. It's about wasting energy and money.
So what's the future of dark skies, and where are you at the moment?
Quite simply, if we can get better control of lighting so that it shines only where it's needed and when it's needed, then the night sky has a very, I nearly said bright future, perhaps that's the wrong word. The night sky has a very good future. But if we allow it to be eroded away by poor quality lighting, then tough luck. Go and collect stamps instead.
If people want to get into sort of astronomy and things like that, or people want to find out how they can, maybe help these kind of causes, who should they get in touch with?
Well, I think if you want to get started in astronomy simply as an observer, go to your nearest astronomical society. They'll be very pleased to welcome you, because astronomers are very normal human beings. They're not they don't have antennae or anything like that. And that's a very good way to get started in astronomy. Nowadays, of course, in the ages of mass communication and information, there are so many different websites that will get you started. Tremendous numbers of good books. Books still exist, happily. If you want to start doing something to help the night sky, then simply look at the website of the Commission for Dark Skies. It's a section of the British Astronomical Association, and that'll tell you all you need to know. There's lots of other websites too about light pollution. And I really must stress the fact that light pollution activists do not want to turn your lights off. They just want quality, star quality lighting that will help us and not destroy the environment.
One very quick question for a very quick answer. What's your favourite sci-fi movie?
Sci-fi. I think Capricorn 1, which is it's about a sort of conspiracy, a plot to fake a Mars landing.
Oh yeah.
And it's a really good and highly watchable film. I think a lot of people have got this moon landing hoax in their heads because of watching the film Capricorn 1. Yeah, so just have a look at it. It's a wonderful film.
Yeah, we'll do.
Yeah, it's sort of sci-fi because it's a sort of incredible situation based on science. Yes, if you'd like to contact me personally, then just have a look at the website of the Wessex Astronomical Society, and there's a contact form there.
Lovely. Okay, well, let's wrap that up there. But thanks very much for coming in, Bob.
You're very welcome.